And for this problem, we are meant to find the critical values of this function, f of x is equal to x squared minus 4x raised to the 2/3. All right, so to find the critical values, we need to find the derivative and then identify where the derivative is either equal to 0 or does not exist. So first off, the derivative, f prime of x is equal to 2/3 x squared minus 4x to the negative 1/3, subtracting 1 from the exponent, times the derivative of the inside, which is 2x minus 4. And so let's rewrite this. We have 2 times 2x minus 4. And then I have 3. And then this is a cube root in the denominator. So I've got the cube root of x squared minus 4x. And so I have to determine where the derivative is either equal to 0 or find where the derivative is undefined. Okay, so first off, let's solve f prime of x is equal to 0. So that means 2 times 2x minus 4 over 3 times the cube root of x squared minus 4 is equal to 0. Okay, now a fraction is equal to 0 exactly when the denominator is 0. And so I have that 2x minus 4 is equal to 0. And so I have x is equal to 2. And so that is one critical point, the place where the derivative is equal to 0. Now I'm not done yet. I have to find where f prime of x is undefined. And so this is going to be undefined where the denominator is equal to 0. And so I need to have that the cube root of x squared minus 4x equals 0. Okay, cube both sides, I get x squared minus 4x equals 0. So x times x minus 4 equals 0. And so I have two places where the derivative is undefined, x equals 0 and x equals 4. And so combining the two lists, that'll be all my critical points. The critical points are going to be these three numbers listed in order, 0, 2, and 4. At these bottom two places, the derivative will be undefined, and at 2, there will be a place where the derivative is equal to 0. Now, before closing the video, I'll mention that 0 and 4, I can plug 0 and 4 just fine into the original function. If I plug 0 into this, I get 0 to the 2/3 is 0. If I plug 4 into this, I would get 0 to the 2/3, which also is 0. So the function is perfectly well defined at 0 and 4, but the derivative is not defined at 0 and 4. It turns out there's a sharp corner at those points. And so this is a instance where the function is defined, but the derivative is not defined at those 2 points.